Welcome to the next video in the binary series. In this video, we're going to look at a different way of expressing negative numbers in binary, and this system is called the excess notation. So the excess notation also comes with a set of digit lengths. So basically you can talk about 3 bits excess notation, 8 bits excess notation, 6 bits excess notation. So you have to fix the length of the binary code. The difference here is that 0 is represented by 1 followed with as many 0 as necessary. So for example, in 4 bits excess, 0 is equal to 1 followed with 3 zeros. In 3 bits excess, 0 is equal with 1 followed with 2 zeros. In 5 bits excess, 0 is equal to 1 followed by 4 zeros. So straight away you can see that 0 is not a signless number anymore. It's neither positive nor negative, but we attach 1 to it. Every positive number in excess notation has got a 1 to start with, so 0 will make a positive number in this notation, which isn't very good. Hence, one of the reasons why this notation is not as widely used as the 2's complement. Now, let's see how we can build up the excess notation. Let's start with a reasonably simple example. Let's talk about the 3 bits excess notation. So, because we're talking about 3 bits, we have got 3 place value units. So, the easiest way I can build up the whole notation here is remembering that I have got 1 and 0, which is 2 different bits. And if I wanted to build up 3 bits length units, then what I can make is 2 to the power of 3, 8 different variations, which easily can build up by placing 4 ones, 4 zeros, then 2 ones, 2 zeros, then 1 0 1 0 alternating. And now if you can see what I've done, I've built up all the possible combinations of 3 bits binary numbers, but in an order where they go from the smallest to the biggest. Now with the excess notation, this is your starting point, this is your 0. So this will be positive 1, that is positive 2, this is positive 3, this is negative 1, this is negative 2, this is negative 3, and this is negative 4. Straight away you can see that because I assigned a positive number to 0, I can only use 1 less numbers for positives. So with positives I can only go up to +3, but with negatives I can go down to -4. The other peculiarity about this system is that if you look at the 0, which is 1 0 0, if you invert all these digits, you end up with 0 1 1, which is -1. So by simply inverting the digits, you don't end up with positive 1 being equal to -1. You end up with 0 being equal to the opposite of -1, or -1 being equal to the opposite of 0. So again, that's a slight peculiarity that we need to be aware of when it comes to the 3 bits excess notation. Other than that, it's relatively simple to build up. So this is the 3 bits excess notation, and let's say if we wanted to find what is positive 2, well, I can quickly build it up, as you've seen, and positive 2 in 3 bits excess notation is just this number. So positive 2 equals to 1 1 0 in 3 bits excess. -1, again, is here. So -1 in 3 bits excess is 0 1 1. And -3, the last example, is equal to 0 0 1 in 3 bits excess notation. So how about if we wanted to increase the length of the system. So what if we wanted to look at a slightly longer system and we wanted to find out about numbers in 4-bit success notation? Now, I have got 4 place values that I can mix up my digits of zeros and ones. So altogether, I have 16 variations, which tells me that I can build up the whole 4-bit system by placing 8 ones and 8 zeros. Then I can place down 4 ones and 4 zeros, and 4 ones and 4 zeros again. Then I can have 2 ones, 2 zeros, 2 ones, 2 zeros, all the way down. And then just repeat them one after the other, alternating the digits all the way down. So what I ended up with here is all of the possible variations of placing ones and zeros into a 4-bit length digit, but in an ascending order. So again, what is the main point of the 4-bit success notation? Is that one followed with zeros, we set it to be equal to 0. So the numbers above it, +1, +2, +3, +4, +5, +6, +7, -1, -2, -3, -4, -5, -6, -7 and -8. And again, remember that with this one, because I assigned a positive digit to 0, I can go down 1 extra bit with the negatives. So now I have got every possible 4-bit success notation numbers in here, and whichever I need, I can just easily read off. For example, if you were asked what is +4 in 4-bit success notation, that is this one. 1 1 0 0. What is -5 is this one. 0 0 1 1. As opposed to the 2's complement notation, negative numbers here now starts with 0 and positive numbers starts with 1. So again, another difference between the 2 notations. Now you might ask the question, why do I want to write out every single possible combinations when I only want to have, let's say, -3? So how can we go about that? Let's say you don't really fancy writing out all those things, so how can you have a shortcut? So you've got the 4-bit success notation, but you just want to find, let's say, -3. So what we know about -3 is that it's the opposite or inverse of +2. Be careful, -3 and +2 are inverses, not -3 and +3. So another thing, 1 0 0 0, that is my base point. I know that is 0. So how am I going to go up to +2 in here? 1 0 0 1. I increased the value of these digits by 1, so this one will be my +1. And if I increase the values up by 1 again, this will be +2. Now, to be able to use this method, you will have to be quite familiar with counting up in binaries. Now, I found +2, so -3 will be the opposite of it. So -3 will be, I just need to invert all of these digits. So let's pick out these digits and invert them. 1 becomes 0, 0 becomes 1, 1 becomes 0, 0 becomes 1. And this is equal to -3. Let's double check ourselves. And yes, this is -3. Now, you can get quite unlucky and you can be asked a higher number in here, so you would need to do a bit of a higher calculation up. But by now you probably are relatively familiar with the binary number system, so it would not be such a huge problem. Another complication, another difficulty with this system is that when you start to look at these binary digits and you start to do addition with them, then you will find out that the addition doesn't work in the normal way. It actually works in the positive numbers, but if you start to think about adding -4 and -3 together, do you end up with -7? So there are troubles with addition in here. So that's another reason why the excess notation is not so widely used anymore. This is what I would have liked to talk to you about, the excess notation, just to expose you to a different way of expressing negative numbers. Now I'm going to let you try a few of them yourself, look at the practice questions, and you will have the answers later on. So these are the practice questions. And here are the answers.